The two videos you are looking at right now use the exact same action design. The first action is the girl turning around to show off her outfit. The second action is her making a peace sign with her left hand. The third action is her sticking her tongue out. The fourth action is fixing her hair. And the fifth action is her winking at the camera and blowing a kiss. Notice that there are quite a few actions happening here. So what this video is testing is not whether the model can generate a pretty character, nor is it about completing a single action. What we are really testing is whether the model can perform all 5 actions, one by one, in the exact sequence we wrote. Now, this gets really interesting because in our previous videos, we introduced a similar technique called prompt relay. At that time, we applied the prompt relay technique to the LTX 2.3 model. Ultimately, we figured out that this technique isn't just limited to LTX 2.3. It can absolutely be used in Wan 2.2 as well. And what is really surprising is that in Wan 2.2, its control over actions is actually much more precise. Let's take a look at the results from these two groups. First, let's look at the LTX 2.3 side. We can confirm that it is not completely unresponsive, but it only shows a few of the actions in the sequence. Now, let's look at Wan 2.2. Things are quite different here. Its understanding of actions is much stronger. You can clearly see that it tries its best to push through the actions we set, step by step. We can't say every detail is 100% perfect, but the overall action sequence is much more complete. Of course, it also has some issues, mainly that the overall quality of the video is actually not that high. So this is exactly the problem we are going to solve for you today. First, you need to learn how to use the prompt relay technique in Wan 2.2. Additionally, we need to understand how the performance of the prompt relay technique differs between LTX 2.3 and Wan 2.2. First, let's introduce a new mode of the prompt relay technique, which we call the timeline mode. As you guys know, the prompt relay technique is not a new model. You can think of it as a prompt scheduler. The regular way to write prompts is to stuff all the content into a single prompt. The problem with this approach is that the model easily mixes these actions together. Prompt relay is exactly what solves this problem. It breaks a long prompt into multiple segments, with each segment corresponding to a specific time period in the video. Here we are still using the ComfyUI prompt relay extension created by KJ. However, I am going to show you a new method called the timeline mode. There is a specific node for this called PromptRelayEncodeTimeline. The biggest feature of this timeline mode is that it doesn't just split the prompt apart. We can explicitly specify exactly how many frames each action segment takes up. Also, there is another crucial concept here called the global prompt. The global prompt is responsible for everything that remains constant throughout the entire video. For example, who the character is, what clothes they are wearing, what the environment is, and what the visual style is. Our local prompts only describe what happens during that specific time frame. Therefore, you just need to grasp this main principle. The global prompt handles the main subject, the local prompt handles the action changes, and the length handles the proportion on the timeline. With this premise, we can compare LTX 2.3 and Wan 2.2 to see exactly what the differences are when they render the same action prompts and whose execution ability is stronger. Alright, next, let's take a look at the workflow. For easier demonstration, I have also built the workflow on Running Hub. In the ComfyUI space, Running Hub is a fantastic online platform because whenever new models and extensions drop, it always follows up immediately. Moreover, Running Hub provides an online communication platform for ComfyUI creators. You can find tons of creative inspiration and practical workflows on there. First, let's take a look at the Wan 2.2 prompt relay workflow. The structure of this workflow isn't very complex. It is essentially a Wan 2.2 image to video workflow. We just need to replace the prompt node with the prompt relay timeline control. Next, let's look at the model loading. For the selection of the Wan 2.2 main model, I didn't choose the official high noise or low noise models. I am using a fine-tuned remix model. As everyone knows, this remix model is much more proactive when it comes to expressing actions. Then, we use our text encoder and VAE. To compare it with LTX 2.3, the overall workflow settings are slightly different from the Wan 2.2 workflows we discussed before. First, our resolution is 640 by 960. The recommended resolution for Wan 2.2 is usually 480. As for the total frame count, I am using 121 frames here, whereas in traditional Wan 2.2 workflows, we usually use 81 frames. So when you test this workflow, you might feel that it runs relatively slowly. This is exactly why. Additionally, the frame rates of the two workflows are quite different. In Wan 2.2, we generally use 16 frames per second. Therefore, for the same number of frames, Wan 2.2 will display for a longer time. Now, the most critical node down here is the PromptRelayEncodeTimeline. Inside this node, we can see two layers of prompts. The first one is what we call the global prompt. In this prompt, we wrote a cheerful, beautiful Asian woman with double bun hair, wearing a purple headband, dressed in a black and gold qipao, standing in front of a dark studio background. This is what we mean by locking in the character, clothing, and scene. Below that are the local prompts used to set the actions. The first segment is her maintaining a finger heart pose and starting to sway her body. The second segment is her winking at the camera and adjusting her posture. The third segment is a slight turn of her body, making the headband flutter. The fourth segment is her stopping her hands, placing them by her cheeks, and doing a cute cat paw gesture. The fifth segment is her blowing a kiss to the camera. In here, we also set the length of each action. For example, 23, 26, 26, 20, and 26. Added together, it is exactly 121 frames. This is highly intuitive. You don't have to distribute all the actions evenly. You can assign different frame counts to different segments based on the complexity of the action. The sampling part is also very precise. We use two samplers as well. Our sampling algorithm is UniTC, and the scheduler is simple. This is consistent with our official workflow. Now, let's check out the LTX 2.3 workflow. We've already covered this workflow for you guys before, so let's just look at some of the differences. First is the resolution here. We typically use 720 by 1280. It is relatively higher than Wan 2.2. The frame rate is 20.4 frames per second, whereas Wan 2.2 is 16 frames. Please pay attention. This might be a very crucial difference. Both have 120.1 frames, but Wan 2.2 is at 16 frames per second, so the total duration is about 7.56 seconds. On the other hand, LTX 2.3 is at 20.4 frames per second, so it is only about 5.04 seconds. Let's look at the model section again. Here I am using models provided by KJ. The main model is the VV version, and I haven't loaded any LoRa's here. We also have our audio VAA and video VAE along with our encoder here. We also need an upscaling model because it is still inherently a 2-gen stage workflow. It first generates the base latent and then uses the LTX-V latent upscaler for spatial upscaling. As you can see, the prompt relay nodes for both workflows are exactly the same. The frame settings are also identical. This is mainly to ensure fairness in the comparison. Next, we will do a comparison for you across 3 different shot sizes. First, let's look at the close-up shot. We are still using the first 5 actions, initially showing the outfit, then a left-hand peace sign, sticking out the tongue, fixing hair, winking, and blowing a kiss. Let's see the generated results for both. For LTX 2.3, its image quality is truly fantastic, and the character is quite stable. But when we look at it from the perspective of the action sequence, its problems emerge. Some actions are downplayed, and while some actions appear, the sequence is not clear enough. This is the typical performance of LTX 2.3 in this scenario. The visual composition holds up, the quality is high, but the execution of actions is incomplete. Now let's look at Wan 2.2. The advantage of Wan 2.2 is quite obvious here. It follows the action segments we provided much more diligently, turning around, hand gestures, facial expressions, fixing hair, and finally interacting. The entire process closely follows the timeline we wrote in Prompt Relay. Of course, Wan 2.2 is not completely without flaws. Its details, for example, the details of the hands and facial expressions, might not be as stable as LTX 2.3. In the medium shot test, our character setting is an Asian woman with a high ponytail, wearing a beige dress, carrying a white crossbody bag. The scene is inside an elevator. We have the same 5 actions. The first is looking at the camera and smiling, then slowly tilting her head. Then she leans forward slightly, using both hands to fix her ponytail. Next, she tightens her ponytail and her gaze becomes more intense. After that, she drops one hand and performs a more delicate body movement to add emotion to the frame. Finally, she leans closer to the camera, softly chuckles, and maintains eye contact. Let's look at the final generated result. Because the model has to process not only the character's actions, but also maintain the elevator space, clothing, bag, and reflective background elements, meaning there is more visual information. The pressure on action control is much greater. In this scenario, LTX 2.3's overall atmosphere is decent. The elevator, environment, character texture, and composition are all pretty good. However, the sense of progression between the action segments is not strong enough. Wan 2.2's advantage is very clear. The actions are extremely distinct, but the image quality definitely still needs improvement. Also, as you can see from both examples, Wan 2.2 flickers right at the beginning of the shot. This is a common issue we encounter when using this kind of Wan 2.2 workflow. Wide shots actually expose issues the easiest, because once the character's proportion in the frame gets smaller, many actions become less noticeable. For instance, winking, sticking out the tongue, and blowing a kiss are much easier to lose in wide shots. Here, we set up a dark studio. The character is a cheerful Asian woman with double buns, a purple headband, and a black and gold patterned qipao. 5 actions. First, she holds a finger heart and sways her body. Then she winks at the camera, turns slightly, frames her face with her hands, does a cute cat paw gesture, and finally has a blown kiss. Take a look. The difference is quite obvious. LTX 2.3 still maintains high image quality and a certain aesthetic appeal, but it still struggles with action execution. On the Wan 2.2 side, her micro-expressions weaken in the wide shot, but the phase progression of the actions is still quite strong, especially from the hand gestures to turning around, and then the final blown kiss. So we can see that prompt relay is still highly effective. Through these 3 shot sizes, you will find that prompt relay works better in Wan 2.2 than in LTX 2.3, whether it is a wide shot, medium shot, or close-up. Next, we can guess why Wan 2.2's action control is better in this test. First, the duration of the Wan 2.2 workflow is longer because its frame rate is lower at 16 frames. Per SE-Cond, the video can reach 7.56 seconds. So for the model to perform actions, it has a relatively more relaxed time frame. It has more time to unfold and express them, whereas LTX 2.3's 5 seconds feels much more rushed. Second, Wan 2.2 responds much more actively to action changes. This is an inherent trait of the model itself. It is more willing to make the character move. Even if there are some flaws in the details, it is willing to execute the action. LTX 2.3, on the other hand, prioritizes maintaining the stability of the image in motion first and only then considers the completeness of the actions. Let me give you a few practical tips. First, if you use prompt relay for continuous actions, do not write actions that are too complex. It is best to write only one thing in a local prompt. Second, only write stable information in your global prompt. This stable information refers to the character's appearance, clothing, scene, lighting, and visual style. Only write the changes in the local prompts. Another thing is that if you use the LTX 2.3 model, processing 5 actions is actually quite difficult for it. I think the conclusion of today's test is quite clear. Prompt relay is not an exclusive trick for LTX 2.3. It can absolutely be used in Wan 2.2 as well. And in continuous action tests like this, Wan 2.2's performance seems much more complete. Although LTX 2.3's advantages still exist, it has its own characteristics in terms of image texture, subject stability, and overall style if your current goal is to make the character complete as many actions as possible in a specific order, for example, achieving 5 or more, then I think Wan 2.2 is relatively better than LTX 2.3. We've introduced the basic usage of prompt relay before, which was that smart node, but today we mainly use the timeline node. You guys can give it a try. All right, that is all for today. Follow me to become someone who truly understands AI.